Assalamu alaikum guys, welcome back. Okay, so in the previous lecture we've talked about ionization energy and how it changes up the group and across the period, right, and diagonally. Now we are going to talk about about these trends one by one in detail. But before we move on, and the first one is group. Why does the ionization energy change as we ascend or descend the group? But before we talk about the group, there are the factors that affect the ionization energy needs to be understood, okay, so which I'll be explaining side by side while I'll be explaining the groups. Okay, so let's get started. Now for instance, I have the periodic table right over here, and in the periodic table I've got many groups, right? The first group, the second group, and then third, fourth, fifth, sixth, seventh, eighth, or you could say the first group, second group, and then the 13th, 14th, 15th, 16th, and so on. You guys, I hope, I'm assuming you guys know these, this nomenclature. Now, the first group, I'll choose the first group, which is the alkali metals group. Alkali metals group. Okay, sodium, potassium, rubidium, cesium, and there is a lithium as well, and there is a francium as well in the end. Okay, but I'm excluding both of them just for simplicity. Now guys, what I'll explain you is that why does the ionization energy change over here. Okay, as you go up the group, what else is changing? What else do you guys think is changing? Cesium will have a lot of shells, electron shells around it, right? Rubidium will have relatively lesser shells because its proton number is lesser than cesium, and excuse me, potassium has even lesser shells, electron shells, and then sodium will have the least shells, and then lithium will have even smaller shells, even smaller atoms, basically due to the least number of shells present in the lithium. Now guys, since the number of shells are different, their atomic radius is going to be different for each one of them, right? And as you see, lithium has the smallest radius because of the smallest shells or the least shells, and cesium has the largest radius as compared to them because of the greatest number of shells. So going down the group, I can say that the radius is increasing, right? Apart from the radius, if you guys remember the previous lecture, if you've seen the previous video, I have talked about the term called shielding effect. If you remember, I'll just quickly recap this shielding effect. What was the shielding effect? Shielding effect was basically the opposition provided by the inner shell electrons. So I gave the example of an atom, for instance, over here. This is the nucleus of the atom. This is the first shell, this is the second shell, this is the third shell, and the third shell is assumed to be the outermost shell. Okay, in the third shell there is an electron, and then the inner shell electrons are also filled with inner shells are basically filled with electrons. Now these since the inner shell electrons are also negatively charged and outer shell electron is also negatively charged, what the inner shell electrons do is they actually repel the outer shell electron, and this force of repulsion or this opposition that the inner shell electrons provide to the outer shell electron is called the shielding effect. Simple, shielding effect. Now, and why is it called the shielding effect? Because these electrons are actually shielding the outer electron from the nuclear pull. The nucleus, as you guys know, is positively charged due to the protons present inside it, right? The protons are also positively charged. So this positively charged nucleus will attract the outermost electron towards itself. Now, since these electrons are negatively charged, they'll repel the outer electron in the other direction, in the opposite direction to the nucleus, hence reducing the effective nuclear attraction on this outer electron, right? So that's why these inner shell electrons are said to be providing the shielding effect. So we can derive a relationship over here that the higher the number of inner shell electrons, the greater the shielding effect. Clear? So this is the reason why this is basically the association of the shielding effect with the inner shell electrons. Now as you look at this period, this group over here, sorry, not the period, the group, In this group, as we go down the group, the shielding effect is said to increase. It is increasing. The reason why it is increasing, because the inner shell electrons are also increasing, right? Now, these are the two reasons why the ionization energy changes as you go up the group or down the group. Okay. Now, since we are discussing down the group, the increase in radius and shielding, increase in shielding effect as we go down the group, what are going to be the effect, the result of these two down the group? We are talking about, these are the two effects or the factors, changes that happen when we go down the group, right? Going down the group increases the nuclear size, atomic size. Going down the group increases the shielding effect. Now, remember guys, if the shielding effect increases and the radius increases, can I say that the outer electron is less tightly attracted to the nucleus? Less tightly attracted to the nucleus? Because if the radius is high, that means the outer shell electron is going to be far away from the nucleus, right? It's going to become, it's going to gradually go far and far away from the nucleus. And if the shielding effect is high, then obviously the nuclear pull or the nuclear attraction on the outer electron is going to progressively become weaker and weaker, right? So if the pull on the outer electron, it decreases due to the shielding effect and due to the large radius size, then if it becomes less tightly attracted to the nucleus, then that means less energy will be needed, less energy would be needed to remove the outer electron from the atom, remove the outer electron from the atom. And if lesser energy is needed to remove the outermost electron, what is this energy, by the way? The energy needed to remove the outermost electron is your first ionization energy. Simple as that. So if this energy is low, then this is actually the ionization energy that we are talking about. So the ionization energy is also going to become low. Okay. So now if you are asked on your exams to describe and explain the trend that would of ionization energy as you go down the group, what are the points that you are supposed to write? So let me just clarify them over here so that you guys do not lose any marks. And these are basically the points that I have, through my own experience of past paper solving, have compiled as well, and the teachers also guided us. Okay, so now basically when I was giving my own A levels at that time. Now guys, so what's happening over here? The first point that you need to mention is that as you go down the group, what's happening to the ionization energy? It is either increasing or decreasing. So down the group it is, ionization energy is decreasing. Why is that happening? Now you have to explain. This is the first mark, okay? First point, first key term, first mark. The second, you'll have to explain that the radius is increasing. And then you'll also have to explain that the shielding effect is increasing. Okay, shielding effect is also increasing. Okay, and if the radius is increasing and the shielding effect is increasing, so will the electron become less tightly attracted to the nucleus? Yes, sir. So the outer, by the way, you have to mention this term outer, okay, because it's the outer electron that we are dealing with in ionization energy, not the inner electrons, okay, in first ionization energy basically. Okay, the outer electron becomes less tightly attracted, is less tightly attracted to the nucleus. So lesser energy needed to remove it. And that's it. Okay, this question usually comes for 3 marks. Okay, and these are actually the 3 points. The first 3 points are the key terms, key points, which are usually or in fact almost every time given in the marking schemes. Okay, so this was the explanation of why ionization energy going down the group it decreases and why it increases going up the group. Okay, because going up the group is the reverse of all of these points, right? Going up the group, the radius is shrinking. Going up the group, the shielding effect is decreasing. Going up the group, the outer electron is becoming more tightly attracted to the nucleus. Therefore, more energy would be needed to overcome the nuclear attraction or the nuclear pull. Therefore, the ionization energy has to increase. Now, in the next video, we are going to talk about the changes with periods, okay, the periodic shift in ionization energy. Thank you.